welcome back to Truck Tech, everyone. Good to see you on a Wednesday afternoon. We are coming to you from Michigan like we often do. Sometimes we don't, but part of the show today will actually take us back out to California again. But before we bring Thomas Healy, who is the founder and CEO of Hyliion Holdings, or Hyliion in second reference, onto the show, we want to go through just a few headlines. We've actually seen some news come in this week. Let's start with Cummins. Cummins, which a year ago closed two pretty big deals, one very big deal to acquire Meritor for $3.7 billion, and then about $205 million to buy the commercial vehicle unit of Siemens, is back in the buying stage again. They have agreed to buy two plants from I'm going to mess this one up. Forencia, thank you. Forencia, which is doing exhaust system work with Cummins. Cummins is going to buy the plants both in its hometown of Columbus, Indiana, and then one in the Netherlands. Volvo Group, big number from them this week in Sweden. They announced the purchase by Holcim of up to 1,000 electric trucks. This would be the biggest number so far that we've seen in terms of a single order. This will carry out through the end of the decade for the company, but it is also showing that we're seeing more and more bigger orders. So if you remember back in May, a year ago, Daimler Truck North America announced that Cisco was going to buy up to 800 e-Cascadia trucks. Finally, how many pieces of Lego do you think it would take to build a replica of a Mack Anthem truck? Okay, I'll tell you, it's 1 million. It takes 1 million pieces to do that. There you go. Look at that. Isn't that something? This truck actually was built in Australia, in Brisbane, where Mack Truck is celebrating its 60th anniversary right now in terms of assembling trucks down there. This is quite a project, and we got a bunch of photos. You'll see some more in Friday's newsletter. But this is a tribute, really, to Mack down there, and we just thought it was great to get a chance to look at the finished product. Okay, let's get in the show, shall we? Bring on Thomas Healy. Thomas, it is great to see you. Saw you at ACT Expo. Of course, we're going to spend a little bit of time out there together in the show today, but that comes a little later. I guess by way of introduction, you're a regular on our air. You're a fan favorite, I think, or at least you're a favorite of ours. And from the time that you were just getting started as a public company. You've been on. You've been wonderful about sharing what's going on with the company and pushing the whole HyperTruck activity. It is interesting that I didn't realize this until I looked today. You have 5 patents of your own. You also, and we know you were the punter. We did not know, however, that you're now a member of the board of trustees at Carnegie Mellon, which is pretty cool. Just since May, I guess.
Yeah.
That's great. I mean, I don't think you have to take football with you. I think they'll probably have you without that now, right?
They don't want me going back to my football years. That's well behind me. But I was very honored to be invited to join the board of trustees of Carnegie Mellon. Had my first meeting a few weeks ago. Got to go to commencement. The big changes, as opposed to sitting in the football stadium watching the speakers, now you actually get to sit on stage when you're a trustee, which was pretty neat.
Wow, that's pretty cool. Have you turned 30 yet, by the way?
I did, yeah. So I'm officially no longer an under 30, so no more 30 under 30 awards or anything like that. Now I'm in the 40 under 40 bracket.
I was going to say, you got the 40 under 40. You've got a number of years to pull that off, I think. Anyway, welcome to the show. Great to have you. We mentioned the ACT Expo, and I just, before we get to what you and I did the walk around out there and had some fun with that, as well as I think some really informative stuff. I want to ask you a little bit about the business. I went through the transcript from your earnings call from last week, or from the 10th, I guess. And, there were a few questions I wanted to ask. I know some of these are going to be more difficult for you to answer, simply because, you can't go very far beyond what you told everybody. You can't just tell me something. Well, you can whisper it in my ear, but anyway, you can't go very far. You can't go very far beyond that.
But I'm going to get into SEC trouble here. All right, so
I'm going to try. Really, I'm going to count on you knowing how to stay out of that trouble. I might push you there. I don't know. Anyway, On the call, you said that there's some over-engineering in the HyperTruck ERX. And first of all, I'm going to let you explain what that is, the first version. But you said there may be some things you can do to, pull some cost out and that kind of thing. You want to talk about that for a minute?
Yeah. So as we tasked the team with going out and designing, developing the HyperTruck ERX, safety critical was number one. And then number two was make sure this product is robust and reliable, and people aren't going to have field failures and issues with it. Now, no doubt there are going to be things, or will be learnings, but we wanted to make sure the product was robust. With that, there were some things that were over-engineered. We found, the capacity in the cooling system has more than maybe what we actually need. The actual sheet metal of some of the components is thicker than what is needed. The design is more robust. So as you think about going from the first stage of having a safe, reliable system to then the next stage of let's look at areas where we can pull cost out of this system, it allows you to redesign some of the components, make them less rugged to pull some cost out, but obviously still meeting those thresholds of what the industry expects of a truck that isn't going to be broken down on the side of the road.
Sure. It's interesting that you brought forward the actual beginning of production. I remember a year ago, you did have to step it back a year, but now you think you're going to have some trucks ready to go in the third quarter, which is a quarter ahead of what you've been saying. But it's also interesting because you're not going to do as many as you said. I think you originally indicated 210. Was that by the end of the first quarter? I'm not sure. Now you're looking at about 30. So this is a way, I guess, to save some money, conserve some cash. You don't have to buy a lot of parts if you're not finishing the assembly, right?
Yeah, so I can dive into a lot of details on this, but really, if we step back and look at what's going on in the market, Hyliion is positioned well from a cash standpoint. We have about $385 million on the balance sheet as we closed out last quarter. So, as you know, that's one of the big strengths we have compared to specifically some of our peer sets, and we want to make sure we use that cash wisely. As I shared on the earnings call, where we were a year or two ago, the market was rewarding high revenue growth. Now, where we are today, the market is more rewarding path to profitability and making money on systems. So when we initially laid out the plans for rolling out these initial trucks, we were okay with taking some losses on them. And frankly, we're still okay with taking some losses on them in the initial ones. But through that time, as we got those initial orders to where we are now, we've also seen some of our bill of material costs go up, just thanks to supply chain, right? Our suppliers are seeing surcharges on their components, and then they're having to pass those on. So naturally, our look at it is, okay, well, we should take those price increases and also pass those on to our end customers so that it doesn't put us in a position where we're just sitting there holding the bag, losing a significant amount of money on these trucks. So that's the plan is, a few different things. First is, you're exactly right. We initially were thinking late 23 is when start of production would happen. We're pulling that to the left. We're actually going to start doing the initial builds in Q3. But as opposed to doing the hockey stick growth ramp, we're going to go a little bit flatter. So as you mentioned, initially the plan was ship all 210 Foundries trucks by the end of Q1 of 24. Now what we're saying is we're still going to start production, or we're going to accelerate start of production in Q3, and we're going to ship 30 trucks by the end of the year. So a little bit different timeframes there. And we're going to continue to ship as we go into 24 and plans to ship hundreds of trucks in 24. But we haven't put clarity yet on what exactly 2024 is going to look like. But the team's rallying around, let's get the initial 30 trucks out there by the end of this year.
Right. Who is doing those builds? You mentioned on the call that you really didn't want to be assembling a lot more trucks. Who are you working with to build these or assemble these first 30?
So initial plan is we're doing it at our location here in Austin, Texas. So trucks are going to be produced on Peterbilt's production line up in Denton. And then we're going to bring them down here. We're going to do the installation of the powertrain, the full bring up of the system. And then they're actually going to go back to Denton. They're going to go through final end of line certification. The VIN is going to be put on the vehicle. And then from there, we'll work to get them to the customers. So, initial installs are happening here in Austin, but as we've laid out on our roadmap, it's going to be, start here, then look to utilize mod centers. And then from there, long-term goal is you actually get pulled on to the production line at the OEM. Now, as you know better than I do, that's OEMs want to see you producing good quantities, having strong customer pull behind you, and then they'll look to pull you on the line. And so that's our goal, is we're able to scale to get to that point.
Well, that's pretty exciting about Denton, because I was just in the plant a couple of weeks ago myself, the first time, and we saw. And what's that?
It's a pretty neat place, right? It's
It
a very
is,
neat manufacturing.
I realize that automated guided vehicles are not new in this industry, but the work that they're doing to really take what is a 43-year-old plant and widen it out, and a lot of things they're doing we don't need to go into. But it's fascinating to me that you are actually, you're going to get essentially your glider from them, and then you're going to install the powertrain and you're going to send it back. And the interesting part is that they're going to be doing the end of line validation presumably for you, which I think is amazing. That's almost like having them build them, right?
It's a step in the right direction, or a big step in the right direction. Obviously, when we started this journey, we were buying complete trucks, right, that had transmissions, drive shafts, conventional axles on them, and then we were ripping all those components out of the vehicle to then go put in electric solutions. So being able to avoid that, right, get a chassis that doesn't have any of the parts on it that we don't need, only has the things that we are going to continue to utilize, allows us to be more cost efficient, allows for quicker installation, and ultimately just a better end product going to the customer.
Sure. Well, it is exciting. And so your mods are those like Fontaine, and I think you had one there in Texas as well for kind of next stage. Is that right? Is that who
you're working with? So we've previously mentioned Fontaine, and then Lone Star, which is up in Texarkana. But then we're also looking at other solutions as well. If you look at Peterbilt's location, they've got CVS right next door. So we're looking at the different mod centers that are out there and trying to make sure that we're being as efficient as possible, right? And
Sure.
And obviously, moving a lot of trucks around to different locations is not the most efficient setup. So that's where we want to streamline the installation process as much as we can.
Right. You mentioned the founders trucks, and I think you said on your call you have 11 founders sort of companies that are getting them. You also said, I think, that you want to expand that number because, and I can only assume, you can answer me or not, but can only assume that's because some people have gotten a little skittish, as costs have gone up, as the market is, the capacity is very loose right now and things like that, and everybody's looking at their bottom lines. I would assume, and you can tell me if I'm right here, you want more founders companies because maybe the companies that you had aren't going to take all 210 of those trucks. I don't know that you can even get there, but I have to ask.
Yeah, no, absolutely. So as we shared on the call, we're going to be going back, and we have actually already started this process, going back to those fleets, and we're going to be passing on some of these price increases. And so we need to get through those dialogues to see what the response is, and then we'll be able to share more on that end. But more the increasing the number of fleets was more driven by, kind of the philosophy of if we're only going to have 30 trucks by the end of this year, just to take it to both ends of the extreme, would you rather ship 30 trucks to 30 fleets, or would you rather ship 30 trucks to one fleet? I would much rather do the 30 trucks to 30 fleets, because then as we're going to go scale up volume, then you have 30 fleets who have already experienced the technology, hopefully have very positive things to say, hopefully are at a point where they're saying, I want to buy more. And then we'll be able to, as we go into 24, those hundreds of trucks we'll be building, we'll be able to deploy those with those fleets. The risk with shipping 30 trucks to one fleet would be, let's say they decide that's all they want to adopt, or that they only want to do a small order, or maybe the technology is not the right fit for them. That kind of is potentially shooting yourself in the foot. So we have a great batch of the initial fleets that we've been working with, but we want to also bring in other ones if we can as well, so that they can experience it. And then as we're scaling volumes, we've got a stronger or a broader customer base already set up.
Well, it makes perfect sense what you say, because most people are buying 1s and 2s, 5s and 10s of trucks now. I'm thinking of pure battery electric trucks. They're not going out. I mean, there are exceptions, but they're not going out and saying, give me all you can right this minute, because you've got infrastructure, which again, you don't have the infrastructure problem that a battery electric does, right, because you can, you make your own electricity. Now I think what we need to do is go back out to California, you and I think we need to take a look at the new thing that you've got going. Let's go take a look.
Welcome back to Truck Tech. Thomas Healy is a regular and a friend of the show. We wanted to take a few minutes and walk around the Karno. And do not think Karnak, do not think Johnny Carson, those of you old enough to know. This is Karno. This is technology that Hyliion purchased from General Electric in 2022 with the eye towards a second version of the HyperTruck ERX. Thomas, great to see you. Let's take a walk.
Thanks for having me on once again. So as you teed it up, we've got our range extender electric powertrain, right? And what we're bringing into production later this year is the HyperTruck ERX. It's the natural gas range extender. At this show, it's the first time we unveiled the HyperTruck Carno. We've spoken a lot about it, but no one's actually seen it up until this show. So one of the first things you'll notice is the hood is different, right? You've got now this slant because we redesigned it so we could get more airflow through the radiator, because we no longer have a generator under the hood.
And you have essentially a frunk, is that correct?
It's as when we had it open earlier, someone was like, I can fit my golf gloves in there. Yeah, no, it's a frunk.
Okay, all right.
Without the storage.
Yeah, okay, gotcha.
But then now we've got the Carno generator down here, and we've heard it's a fuel cell, it's a flux capacitor, it's who knows, right? But what it is, it's a linear heat generator. So what that means is you've got a piston rod setup that's oscillating back and forth inside this cylinder, and then the middle here is an electric motor that sits there and produces electricity as you're driving. So like in the HyperTruck ERX, where you use that nat gas Cummins engine to produce the electricity, now the Carno is what's actually providing power to the batteries.
But the fuel agnostic, I think, is what you called it.
Yeah.
What's the most likely fuels that you would use in there when you're starting? What are you using now and tested?
Yeah, so actually this truck, which I think, as far as I'm aware, is a first of a kind, it actually has both hydrogen and natural gas storage on the same vehicle.
Okay.
So what are fleets going to use? I mean, the reality of, are they really going to get a mixed fuel truck? Probably not. The Carno's fine with it, right? But it really comes down to the tanks. So we see hydrogen as being a very viable fuel, nat gas being very viable. And then there might even be different applications, industries where propane has been conventionally used. This can run on that as well. You also can run this on conventional fuels like diesel, gasoline. It really doesn't care what you're putting in. It's going to take it and make heat.
Do you need to flush it between uses?
You do not. And you can actually go from running straight on nat gas to straight to hydrogen to even do a mixture of the two. And the software all controls how much fuel it needs to be brought in based on what fuel it's running on.
So let me ask the question a different way. What's the maintenance on something like that?
Yeah, so it's designed to be extremely low maintenance. So heat engines, one of the key applications that it's been used in over the past over many decades is actually in satellites. Reason being is once you deploy a satellite, you can't go up there and service it and maintain it. So there's actually no routine maintenance that we can think of that you would need on. There's one moving part, oscillates back and forth. It oscillates on air bearings. So basically we're hovering with a gap of air in between the rod and the
Like an air gap computer?
Little different.
Okay.
Yeah, but yeah, you've got air bearings, so there's extremely low friction or close to no friction. But we've got a great material on the inside that we do have a piston ring seal, but we're expecting that to last, by far the life of the genset. So the only time you really need to maintain it is if something were to break.
Life of this system?
Yeah, so we're targeting what would be the life of a truck. I mean, we're still in the development testing phases of it all, but there's no reason why this shouldn't be able to live the life of the vehicle.
1 million miles.
That's the target, yeah.
So Thomas, this looks like it might have been a child's toy at some point. I know it's not.
So this is one of the cylinders, right? So on the truck you just looked at, there's 4 cylinders. Each one of these produces about 50 kilowatts of electricity. So on the truck, we're at a 200 kilowatt output. Now, one of the very unique things is this is designed to scale based on the application. So if you think about the industry's used to 6 liter, 9 liter, 12, 15, right? Different sizes of engines. But when you move from one to the other, it's like for an engine maker, that's a huge change. For us, if we want more power, we just add another cylinder, right? Or another 2 cylinders. So if we're looking at an over-the-road application, we're thinking 4 cylinders. Heavy haul, we're thinking 6 cylinders. Lighter duty vehicle maybe only needs 3 cylinders. So that allows us to be able to supply a lot of the market, but without having to do total tear-ups of what this actually is.
What's the weight of a cylinder? What was one way?
So we're targeting to get comparable power to an internal combustion engine. We'll be in the same ballpark of weight. So, this isn't really a weight savings focus. This is more about, it's got increased efficiency, it's fuel agnostic, and then from an emissions standpoint, we're seeing significant decreases in emissions, and it's hydrogen capable where you're going to have zero carbon emissions.
Okay, so how does this thing work inside?
Yeah, so in the middle here is an electric motor, a linear electric motor. Then you actually have a piston here, and you have another one on this side. That's just shifting back and forth this whole time. Now, what most people think is, okay, well, the way it works is you explode a fuel here, it pushes the piston this way, and you do the opposite. You have to almost take everything you ever learned about internal combustion engines, throw it out the window, because this is now a heat generator. So what happens is, from here to the other end, the part's not there, but to right past the cylinder, this is completely sealed. Inside of it is a working gas that our whole goal is we heat that working gas up. When gas gets hot, it expands. That's going to push the cylinder down, or the pistons down this way. Then you do the reverse. But your sealed system never gets exposed to the fuel, to the air coming in. That all happens out here, and the only thing we need to do is transfer the heat into the working gas, and then it starts oscillating back and forth. So it's not an internal combustion engine, but a lot of people get confused or think it is because it has some similarities.
Right, and so the fuel that you're using, the different fuels that you're using, do they go into each piston, or do they go into?
Yeah, so if you come around to the back here, so this is really the one of the areas where we transfer the heat into the working fluid. So out here is where we react the fuel. We do flameless oxidation to convert the fuel into heat. So we don't really care if it's natural gas heating these up, if it's hydrogen, if it's diesel fuel. As long as we have something that we can react and produce heat, that's going to allow us to let this process start.
Is there any extra heat generated that you have to manage from these?
So heat exchange is that's the secret sauce of this whole thing. So these cylinders here are actually thermal capacitors. So we can actually store heat inside, so that as opposed to just dumping it out into the exhaust, out into the air, we actually can store it inside and then reuse it again on the next cycle.
Recirculation.
Recirculating heat, yeah.
Yep. Okay.
So now we have a battery that's actually for storing heat as opposed to storing electricity.
Now for the layman like me, would that be comparable to regen braking kind of thing where you're reusing the heat?
So little different now. So one of the issues with let's take a fuel cell truck is if you're trying to go down a hill, well, you don't have an engine brake anymore, right? You have regen braking, but then if your batteries get full, you got a problem, right?
Right.
So with this, what we can actually do is you can pump electricity into this, and it actually becomes a chiller because we just do the opposite thermodynamic cycle. So as opposed to heat, we become cold, and that actually burns off electricity. So we kind of have an engine brake, but it's a chiller as opposed to what you normally think of as an engine brake.
Well, having no engineering training, you've done a really good job of making it as simple as possible. Thomas Healy, thank you. Great stuff for Truck Tech.
Yeah.
So Thomas, I see some real interesting stuff here. This is what?
Yeah, so these are actually some of the components of the generator. And one of the things that we focus on is we want a really compact system. Well, we found that if we use 3D printing or additive manufacturing, we can completely rethink how components are made. So let's take this, for instance, this is actually a heat exchanger. You could never produce a part like this through conventional practices. There's just no way to CNC, mill, lathe a part like this. But with 3D printing, it's now a new world of opportunities. And we actually designed our parts around 3D printing. So now when you think about heat exchangers, or for instance, this part here is actually the fuel injector. This is how the fuel comes in. We can rethink how we engineer these components, which allow us to get much better efficiencies and make the system a lot smaller.
And with additive manufacturing, you can use any number of materials, whether it's, metals, obviously, is a big thing. And what are these being milled out of?
Yeah, so we have a mix of materials. So these are cobalt chromium. We have aluminum. We can do steel as well. So it's a variety of what we make of, and it all depends on what stresses that component's going to go through.
Right.
So if it's a component that's really involved in that heat transfer, it's going to get super hot, we're going to want to use something like a cobalt chromium.
If it's more just there to hold some components, aluminum is great.
Okay, so great tour, Thomas. Listen, it has been great having you today. I want to thank you for coming on. I also want to do a little shout out to Valentina Kalaman, who did that video for us. She works with you, and we really appreciate her help here. Folks, next week, we will be back with another show. We'll have Ali Javedan, who is the founder and CEO of a truly new startup called Range Energy. They're working on an area for electrifying trailers rather than trucks. So we'll hear some more about that next week. And we will have a new newsletter on Friday for you, looking at, of all things, buses. Why buses? Well, you'll have to read and find out. Thank you all for joining us. Have a great week.